Okay, so we will start from here now. We learned in the last lecture, we learned about first part of our lecture. We learned about how the theories actually basically how two forces can be calculated for different charges. Forces can be calculated due to different charges, and the electric forces can be calculated due to different charges, and electric field strength and intensity. Okay, so with this example one, we will learn how to literally calculate those. So the given charge is the point charge. Two different point charges are given, 1 millicoulomb and -2 millicoulomb. So this is positive charge and this is negative charge, means there will be attraction force between these two, are located at this point and this point respectively. So your Q1 is located here and your Q2 is located here respectively. Now we need to find an electric force on another charge, means Q, which is located here. So this is first one. So this is F, and we need to calculate the electric field intensity at that point, the same point. So we know we will use two different equations, that's all. So it's not so difficult. So here F is equal to, we know that summation of this. So you don't need to use this equation, just directly put this equation and then you expand, because there are two different, let's disregard this, okay, just consider these two. Okay, so we have two different equations when we expand this one, because k is equal to 1 and 2, because there are only two is given right here. So Q1 and Q2, there is no 3, 4, 5, 6, no. So if we expand, so this stays, so Q 4 pi epsilon stays, and then this one, what is this? R minus RK. This is R minus RK, means this is R1, and this is R minus R1, and this is R minus R2, which is Q2, this one. And then this one is the absolute value of this Q. So like this, you practice actually. If you have problem, you can tell me. And then after this, all the values and differences that we get, we calculate and we find out. This is milli Newton. They call it milli Newton. It's up to you. If you don't put milli Newton, no problem. You can put directly Newton. Then it will be like a little bit difference. So you do this by yourself, practice, and if you have trouble, you can tell me. Okay, you can discuss with me. I will help you. Now we know that sorry. Okay, we know that F E is equal to F divided by Q, as we know here, from here, F Q, right? Either you can directly divide it by Q, or you can use this formula. It's up to you. But you know, we already have F, right? So we just directly divided with the given Q, which is 10 nanocoulomb, and then with the 10 nanocoulomb we get this. So kilovolt per meter. So you calculate, you practice by yourself. I would not do this practice and everything. You have to do it by yourself. Once you do, you will know. Okay. So this equation, this example is done. Let's move on to another example. So only here we will calculate the vector field. Determine the vector electric field at this point due to the point charges of this and this. So let's go and try to solve it. Now this is not there anymore. Let's say the Q is not given, means we don't want Q. Okay, so the point is given. the point here is 1, minus 3 and 7. As we know that we don't need Q to calculate the electric field, we need only Q1, Q2. So the individual things that we will learn. Now for R we know, similarly we know that this is given, right? So R is AX minus AY, 3AY plus 7AZ, right? This one. So R1 or R1 dash is 2AX, there is nothing, plus 2AX plus 4AZ, right? Yes. And R2 is equal to here 3AX plus 5AZ here. So now we know, and then we apply in this formula, this formula, expansion of the formula here, also here like this, and then we calculate, and then we get this one. The calculation part is totally up to you. You need to practice this one. You have trouble, you discuss with me. There are two ways I have made it. One is the point formation here, see? This is the point formation. So the coordinate formation, calculation with the coordinate formation. So 3, 1, 2, I used it. And here, I use another way to do it. Sorry. Here, another way I did it is, I made them vector first, and then use those vectors here. So don't get confused. You can do in either. Okay. You can do with this one, with the point from here also. So use just points here, no problem. And either you can use here vectors also. It's up to you. Okay. So in the assignments, it's up to you how you want to do it. Now we move on to our charge distributions. That there cannot be only Q1 and Q2 and Q3 and Q4. These are the point charges. But there are other also way of charges. Like there will be a bunch of charges together, like line charges, surface charges, also volume charges. What we call them are actually charge distribution. There are 4 types actually, charge distribution. One is point charge. That's what we so far dealt with. These are the point charges. Another way of charges are line charges, means a charge stream which is actually follows a line. Okay, so we call it line charges. Another is called surface charge, means a surface full of charges. Okay, now another way is that total volume charge, means an object full of charges. Not only one charge, not a surface charge, not a line charge, it's inside and out and full of charges, like a 3D charge. So for this, different densities charges, like this one is only called coulomb, right? But this is called coulomb per meter. This is called coulomb per meter square, and this is called coulomb per volume, means meter cube. So these are already here. So this one we call it rho. Don't confuse with the cylindrical coordinate system rho. Rho L and rho are two different things. Okay. So rho L is the amount of charge in a line charge. Rho S is the amount of charge in the surface charge, and rho V is the amount of charge in a volume charge. By the definition, actually, they can be determined by 3 different ways. So as we know, to calculate as a line charge, you integrate it once. So we got rho L not only. So this is our total Q. So the Q, this is the charge density, and this is total Q. So the Q means total charge is equal to length multiplied by the charge density. Okay. So that for line surface charge, the total charge of that surface is equal to the surface charge density multiplied by the surface, which is actually called surface charge density. And similarly, this one. Remember one thing, for line charge you integrate once, for surface charge you integrate twice, and for volume charge you integrate 3, because there are 3 variables here. There are 2 variables here, this is 1 variable, because this is single line, this is line and length, length and width actually, and here the length, width and height. So this is the 3 way of differentiating. Now you can see how it happens. This is point charge that we know already. So if we want to find the electric field due to point charge, it becomes like this. Now for the line charge, this Q is replaced by rho L dl, because we know the Q of total line is rho L, right? But from the differential distances, we know the differentials, we know that this is supposed to be dl. We learned in our previous lectures. Okay, so the differential length we need to add, so it becomes dl. So here, so Q we replace with rho L dl. Similarly, for surface charges, we actually we replace this Q with rho S ds here, and this become like this double integration. So this comes out, this R stays if there is anything, but if it's constant it goes out also, and this stays here. So the surface charge, due to this surface charge, what is your electric field in this point due to this surface charge, like this. And also for this volume charge, what is the charge, what is the effect on this point due to this volume charge, means like what is the electric field intensity or electric field in strength at P point for this field volume charge density, volume charge density. So we change it, the Q, we replace it to rho V dV, where dV is equal to, we know that there are 3 integrations. So that is how actually we calculate. Later on in one example, we can learn about it. So we move on to some simple identity. We will not derive it. We will just I just want to tell you actually. So for the line charge, let's say a line charge, if you have a point due to the line charge, if you try to integrate like this, so this is your equation. So you need to memorize it. If you don't memorize, no problem. I will add this in the your final exam sheet or any other exam. I will add this equation. So don't worry. If it's an open book, then I will not. Then you have to find it by yourself. So I don't want to go for detailed integration and how we find it. If you need to study more, you can go to Sadiku and then you see how they got it this from here. So we move on to, this is for the line charge, and this one actually for the surface charge. So they have done it. You can check here how they have done it is because this is surface charge, right? So the area, let's say the rho, we know before from here already that rho is equal to Q total divided by the area, right? The charge density of any surface is equal to the total charge divided by the area, right? So here you see the PS, the rho S is equal to total Q total divided by A. A means what? The area of this circle, right? So pi A square, which is the radius is A. So we get this one. So now we need to find the S, ds, right? ds means what? There is no z here. So rho d rho and d phi we have. And r is equal to h a z. R. This is r. So this is only h, right? So h a z, because this is the point P we want to find. So r is equal to h. This is r, which is only h a z. So r dash, which is this one, how much? Rho a rho, because this is the rho side, right? Because this is we consider this one as cylindrical. So the r is equal to, big R is equal to r minus r dash, small r minus small r dash. So we minus it, we get this one. And then we find the modulus like this. So what is this one? R divided by r modulus. So we get this one. And then at the end, we get this. But I will just only come to this point, not more. But for more derivation, you can refer to Shadiku, where from here we directly define the equation, this one. So for surface, if you want to find any electric field due to the surface, you directly can use this equation. So rho s divided by twice epsilon naught multiplied by a z. Later on, we will use this equation to solve problem. So we go to our problem now, and we solve this problem to understand how it works here. So let's see, there are three different charge distributions are given. So the plane x is equal to 2. So the plane x is equal to 2 carries a charge of 10 nano coulomb per meter square, means this is the surface charge, and plane y is equal to minus 3 carries charge of 15 nano coulomb per meter square, means this is also a surface charge. So these two surface charges are there, okay, and there is one line charge. If the line x is equal to 0 and z is equal to 2, means x equal to 0 means here, we are here, and z equal to 2 means here. So this line, okay, on this line have charge, carrying a charge of 10 pi nano coulomb per meter, means this is line charge. So we have three different charge distribution. So let's define this one, x equal to 2. So we come x, this is charge, surface charge. At x equal to 2, they have a surface which is carrying this much, and y equal to minus 3, here we have another surface charge which is 15 nano coulomb, and this is our line charge. And due to these three, we need to calculate what is our E, final E at 1, 1, minus 1. So we now we can decide first that we need to find E, right? But there are three different. So we find E1, E2, and E3. So E1 and E2 from the surface charges equation, and E3 from line charge equation, we get total E. So E1 and E2 actually will follow the surface charge equation, right? Which is this one, because this is surface charge, the electric field due to surface charge. So rho S1 for surface 1 and the rho S2 for surface 2. And the line charge will follow this equation. So we go to our solution. We first try to find out the surface charges, and then we add them. Then we find E3, which is line charge, which is due to line charge, and then we'll add them. Now go to solution here. So we use this one. E1 is equal to rho S1 to epsilon naught A minus. Why it is A minus? Why it is A minus in A minus direction? So I will put that up to you actually, okay? Because it is okay. You can later on discuss about it, okay? But I put this one for you, why it is a minus. Okay, we can later on discuss about it. But the solution is here is in minus direction. Okay, the force is in minus direction. Okay, now we don't need to calculate this one anymore. Okay, we know what is this one is given, right? So this one is around 10, right? So we put 10 here and we know this value, so we put this one and we get this one. Remember, you don't need to calculate this one if somebody asks you to calculate until somebody asks you to calculate. So we have this this for E1. Similarly, for this one, y, this one is AY. It's up to you to find out first. If you cannot find out, I can explain but later on. But first you try to find out. So see, AY is positive here. Okay. So we put rho S2. We know it's 15 nanocoulomb. So we put here, and then we put the value of 2 and epsilon naught, and then we get this one. So E1 and E2 is done. Now the next challenge is to find out our E3, which is a line charge, which seems a little bit we need to find out so many things. Rho L is given. We need to find the rho, which is important, and a rho also. So here we try to find it. So E3 is equal to rho L divided by a rho, rho L divided by twice pi epsilon naught rho a rho. These are two are the similar, but this is different. This is charge density. Remember this one. Now here in this space, we only know that this is our line charge, right? So line charge have a direct distance is actually the r. But how you will find the r? R actually, A is equal to r divided by the value of the r, right? So r we can find directly from here, right? So we come like this. So it is 2 and this is 1, right? And then 3, but it is going away from z, right? So this is minus 3 and this is going towards x, means plus, so it's 1. So we have r is equal to minus 3 az plus ax, or you can write it ax minus 3 az. Now if you want to find the direct value, this is r also, this is rho also, right? So the rho is equal to the modulus of r, so which is this square plus this square. So 9 plus 1 is equal to root over 10. So rho we got. So we got rho, we got r, and now we find a rho is equal to r divided by r. So this is like this. Now we put it here. Once we put it here, we get this and we get this value. So it is up to you actually how to calculate this one. I show you the procedure and how to find the things. For the calculation and precision of the calculation, this is totally up to you. Now we are about to finish our lecture. Here your attendance assignment for lecture 6. So this lecture you need to submit by tomorrow. Okay, I will put up a link. Means this submission have to be by tomorrow. Okay, I will put up a link, and then you solve this one and you upload. Now this is something that in bonus extra point for you, that I give you an assignment to get 1 extra point in the final exam. Let's say you get in the final exam out of 40, you get 20, you will get 21. If somebody gets 30 out of 40, he will get 31 if somebody submits this assignment. So it is I give one more bonus point for you. So if you can submit this one, you will get +1 in your final exam. So that's all from my side so far. Until we see our lecture, we will see each other inshallah in our lecture 7. Assalamu alaikum wa rahmatullahi wa barakatuh.